Okay, another tangent line problem, and this is another implicit differentiation tangent line problem. It's a little bit less involved than the one I did with exponentials. That was 6423. This is 6425, and sorry. Basically, the idea is that this equation between x's and y's here, um, this equation between x's and y's gives an equation for a curve in the plane, and that curve in the plane goes through the point 1, 2. You could verify by plugging in x equals 1, y equals 2. And anyways, so this goes through the point 1, 2. We want to know what the tangent line looks like to that curve, even though it's hard to imagine even what that curve looks like. So basically you're finding dy dx and using the point slope formula, using the finding dy dx, evaluating it 1, 2, using it as the slope. So here's the deal. We find the slope by taking the derivative of both sides to find dy dx. Again, you have to look at it like the two sides of the equation are y is secretly a function of x, and so both sides, the left side is a function of x, the right side is a function of x. Equal functions have equal derivatives. That's where the idea to take derivatives of both sides makes sense. And so the derivative on the left is a chain rule. It's a natural log of x plus y. So x plus y goes on the bottom. The derivative of the argument goes on the top. And then on the right side, there's a product rule for the first term. And then there's a chain rule for the second term. And so there ends up being basically a couple of terms with y primes in them. So it might have been difficult. The difficulty might have been in actually isolating the y prime this time for some people. And the trick is to think that you can split this fraction up here on the left. It's 1 over x plus y prime over x plus y, and then you just move terms around. Okay? And so I put all the non-y prime terms on the left and the two y prime terms on the right. So one of them came from right here, obviously the 3x squared y squared, y prime. The other one came from this, y prime divided by x plus y. I subtracted it off and factored out the y prime. So I've kind of got the y prime isolated. I could divide by that or just leave it in this form if I don't want to look at the fraction. So I just left it alone. Now what I wanted to do to help me find the slope of my tangent line at the point 1, 2, I plugged in x equals 1, y equals 2, and I get this ugly equation, figure out what y prime is. It's just kind of ugly fraction computation. I end up with y prime equals -7/5, but it's not that bad really. And so that's my slope of my tangent line, and then I just go back to the old point slope formula, plug that in for my slope, solve for y, and there we go. And so that turns out to be the correct answer for this one.